Hello developers, let's start developing. I'm Veko and today we will take on the 20th task of the 2023 Advent of Code. You can still see from my map that I kind of skipped day 19 and only get to the first half of day 18. 17 I'm still failing on. I quite like what I read about 19. It seems that we're gonna have to work something with hypercubes, and it's always fun talking about hypercubes. But let's talk about day 20. It seems that we have to run a computer simulation on our computer. So basically, what we get is some kind of logic gates or things like that. So we have two types of modules. We have flip-flop modules and we have conjunction modules. Flip-flops, well, they do flipping and flopping. So we have pulses, a network of interconnected gates, and we have pulses going through it, and we have a low and a high, or 1 and a 0. So if they receive a high pulse, nothing happened. If they receive a low pulse, it flips between on and off. So they have an internal state. If that state is on, it sends a 0. If it's off, it sends a 1. And conjunction modules are basically kind of just a NOR gate or NAND gate, basically. So they remember the most recent pulse of each of their inputs, so they hold the value. They initially default to remembering a low pulse, and when a pulse is received, if it remembers high pulses for all inputs, it sends a low pulse, otherwise it sends a high pulse. Something like that. We will have, and then we have also a button module that actually triggers the whole thing by sending a pulse. We also have something that is called the broadcaster module, and the broadcaster module basically sends a low pulse to everything. Is that right? Yeah. When it receives a pulse, it sends the same pulse to all of these destination modules. So the story goes that we are clicking the button sends a low pulse to the broadcaster, and the broadcaster then broadcasts the pulse. And our input is something like this. That's one of the examples. So we will need to code this and kind of parse it. So of course we're gonna use regexes and a lot of them I feel, maybe not too much. So we have one thing, so I will say we have everything possible inside, and then we have this, and then we have, well, let's not overcomplicate it, and then we have everything possible, and this ends. I will kinda break it down because we do have several options. So this is actually a string of letters followed by a comma, and we have that followed by an, yeah, and multiple times. What does W match in word characters? Yeah. Followed by a word. No, because this comma is actually followed by a space. Yeah. So we have broadcaster and we're taking ABC. And actually this second group is a non-capturing group, so I don't want to capture it because of course I will do a literal split later so that we can do that. And we don't have a word character, we have a word. So we might need this and we might need this. No, it's not a star, it's a plus because it has to be at least one of them. And on the other hand, yeah, the first character is important because we either have a literal broadcast or we have a percent and then letters, or we have an ampersand and then letters. Now, of course, we could make a few different regex that only match the broadcaster or only match the flip-flops, only match the converters or convergers or conjunctions. But we can do that after the fact. But now I do want kind of this. And let's see if this works for other examples as well. Why is this different? Or we just don't have an enter? If it was just A, still doesn't match. If it's on, still doesn't match. If it's on its own, still doesn't match. What am I doing? Oh, what I did wrong was that I kind of hard-coded the name of that specific thing. So now this is better. And let's get the puzzle input as well and see if this thing matches everything. This way I'm overdoing. The initial regex was quite fine, but I want to see whether those are all the cases that we have in the input. If we have something unexpected in the input that only appears in the big input but doesn't appear in the every line, we might have a problem. Oops, not here, here. And now we will just map the lines. Lines.map. For each line, we're gonna run some things. We're gonna say, yeah, match the line. If we don't have a match, we're not gonna throw an exception that that line is kind of bad because we don't want bad. Otherwise, we do have two groups that we need to take care of, and we don't care about anything else. So we can say this is the source, those are the targets, and that's the match. Now, what are we gonna do with this thing, with the source and the targets? Well, yeah, this part is easy. We have the target list, and that's a string array. But what I want to do is to do some more processing of the input. So I need to get first the name and the kind of the source. So we will find and these are called modules. So we will have few different types. We will have a broadcaster and we will have a, let's give them their actual names from the task so that we have a unified vocabulary. So we have a flip-flop and we have a conjunction. And I will have an interface module where it has a type, a source. Does it have a source? No, it has a name, which is a string, and it will have inputs, which is a string array, and it will have not targets but outputs. To be honest, I think better in terms of inputs and outputs. So it has these inputs that are its own and these outputs. And now I will do something interesting because I don't want these to be interfaces because they do have some kind of a behavior. So I will have a class that actually implements that interface. So we have we don't even want to change this, ever want to change this. This is also true. It's called broadcaster. It has inputs, it has outputs, and these are not actually parts of its construction because its inputs is just an empty array. For now, let's have it at that. And yeah, we're gonna need to have another module called flip-flop. This won't be read-only, this won't be a constant because flip-flops have different names and they will have a set of inputs and outputs. No. And the inputs are initially an empty string because we don't know them, but we will get the outputs. And of course, we're gonna have yet another class that will look and feel for now just the same as the flip-flop. So we can do some matching and we can say if source does equal broadcaster, then we have the target list. No, this can go here. So we don't need this. We have the module is, that is the source, which is a, do we need the source as a parameter? Not really. It is always broadcaster. So we just need the target list. And we just need to return it. Because again, this is a map function, which means that now we have this. If it starts with that character, and obviously a lot of people are solving that that task because I got that suggestion. Where is it? Where is it? Yeah, this is the prefix for a flip-flop module. Then we return a new flip-flop module with that source and that target list. If it starts with that, we do that, and otherwise we say that we have invalid input. These are the modules. And what I will do now, I will transform this map to this array to a map. So for each, yeah, we can just do a reduce. Modules.reduce. Something like that with this, but we're not gonna use that. We're not gonna do that. We will say, well, just this. And this says you cannot do that, but then I can say, yes, I can if I have this signature. So, or alternatively, I will just say that this is actually a record of a string that maps a string to a module. So we will have it as a module map. And I might want to do something more now because we have all the inputs, all the outputs, but none of the inputs. I will, and we might want to actually know the inputs as well. So for each of the modules, well, we run through if we are if we have somebody in our list of outputs, that somebody needs to have us in the list of inputs. So we will do that. So we will do another loop output of module dot outputs. Yes, this line. Find that module that we say that we are going to work with and its input push us. And then we just return the module map. So we updated the map and we're gonna do it, so which means that we can define that as a type. So not to say record of this and that all over again, we can say that module map is this, which means that we are actually working with a module map. And now we need to paste it everywhere because we already used a lot of string arrays. It might change something that's not supposed to be changed. It says part 1 and part 2 are returning weird stuff. Because the input doesn't have a length, it has a size. Is it okay now? Who knows? Well, return -1. That should work. Return -1. Now it works. Oh, it doesn't have a size because this is not a hash map. This is just a simple record. So we are not using gets and things. We are just using it as a regular JavaScript object because we are starting with a regular JavaScript object and not a new map. Of course, let's try to see what we actually did. This is a smallish example, so we should be able to see all of it. Cannot read properties of undefined. Inputs should be very well defined, which means that we are this thing is undefined. Let's see what that is. Output and console log module map of output. That means that we're somehow reading a thing that we don't have here. We have A, B, C, and inf, and A, B, C, and inf. So everything should be here. Oh, it immediately creeps up. It says module map of A doesn't exist. Let's see. And that's because we're kind of stupid. We already know that this is a flip-flop, but we didn't strip. We need to strip off that thing, the indicator of that. Let's see it now. Now everything is operational. So let's take a look at what network we created. We have a broadcaster that doesn't have any inputs and has these three outputs, which is totally in line with that. And we have A that has output B. That's okay, but it says that its input are broadcaster and let's call it the inverter, and I can only see A at the broadcaster and the inverter, so that tracks. B has the output C, correct, and B receives data from broadcaster and A, correct. C has an output of inverter and it receives data from broadcaster and B, correct. And the inverter, if we call it, it outputs to A but receives its data from C. So yeah, we have all the inputs and all the outputs now. And we can safely say that we processed this. So the easy part of the task is done. Well, not so easy because the input was looking a bit complicated. Let's try it with the huge example. If this thing breaks anywhere or if it just says I did whatever I wanted to do. It does not. So we do have a problem. That's our whole map and it's quite largish. Yeah, inputs are totally empty for all of them. Just a sec, how did we get that? Are we logging something to the console after we get all? Oh, we actually are logging here. And this time we didn't get that far. So it's gonna say I don't have a thing for RX. Do we have, where is RX mentioned here? It says Casey goes to RX. Ah, that's it. Ooh. And you can see it even here in the actual input. So that might be something magical. I have no idea what that is. Hopefully it's something, it's not an error in the input, it's something connected with something else. So class unknown module. Yeah, of course we're gonna have an unknown module that says, well, I have no idea what you are, and I definitely know the output for you because nobody told me, so that's gonna be an empty array, and we have that. So we actually found that module when we're doing here. So we're gonna need to add some code that says if we have that, then do what you were doing before. Otherwise, we have an input that we never have before, so we're just gonna create an unknown module for that, and we're gonna assign ourselves to the module. Let's see if this works now. Now it works, and we have a single unknown module over here. We might get to know it for part 2. It might be some kind of a, I don't know, terminal output or something like that. But actually, I think that we do have such a case here. Yeah, we have the output thing and an untyped module named output. Yes. So now we can even parse this. It was actually specified. Those are, let's call them output modules. Yeah, we got that. So let's say that's not an unknown, but it's a known, but with a unknown type. So we're gonna have untyped, and now this will say, but no, this is invalid. That's the benefit of TypeScript. So it's not an unknown module, it's an untyped. Great. We have our console our input, so we don't need that, don't need that. And if we remove that, we should just and go back to the initial example. We can run it and just say, well, we did nothing and everything works. We did nothing, but it works. So let's see what the task is now. We're pushing the button. The flip-flop modules, let's start it. We're pushing the button. The button transmits a low signal to the broadcaster, which transmits a low signal to A, B, and C, and then A transmits a high signal to B. B signals a high input to C, C input a high signal to inf, and some more signals are sent. But let's try that. So we can kind of model the button as another broadcaster signal element that is actually cut to that. So now let's create another. Do we need that? Yeah, we need. And since we're here, I'm gonna add some more type guards. Let's add each type guard because type guards are awesome. But do we need them? I guess we don't need them with class. We might. Let's see. Anyway, what does a button do? So the interface module will also have a send signal message. Is this called a signal or a pulse? Send pulse. Does everybody get to send pulse? No. Let's see. Let's see. Let's model the behavior of all of them and then maybe we will extract something. So the button, a button is just a broadcaster. So what the broadcaster does when we call it send pulse method, no, it's not, because let's have it. They're very similar, but the button actually has another type. So we will say type pulse, and we will have it. Yeah, we can say it on and off. We can say it low and high. We can have it as 1 and 0, and I will have it as low and high to keep up with the lingo. So we have the button has a press functionality. Let's see what it does. Button, where is the button module? When you push the button, a single low pulse. I'm worried that we might change this for part 2. That says sometimes we put low pulses, sometimes we put high pulses and things like that. Or if we're lucky, the second part will just be, well, because in the first part we're pressing the button 1000 times, and they will say in the second part, well, now press the button a trillion times, which means that you need to find the system state and then see when it repeats. But just on the off chance that we have that now it sends one high-low pattern, things like that, I will say the button receives a signal. And I can teach Copilot to do everything except this. So for each hmm, hmm, we will need this method. So all of the modules should be able to receive except the button. Yeah. So the button should never ever receive a pulse. If we get to a situation where the button actually receives a pulse, we messed up something. So the button does have a press method, and which means when we press the button, each of its outputs, which should be just the broadcaster, but who knows, they need to receive that thing. But we only have the strings, so we have two options. Whether each module receives whether each module receives another parameter, which is the map, and we're gonna have to do it in a half-baked way, or or this just needs to be done in some kind of a management thing, or we need a global variable? No, each of them has a, let's not overcomplicate it. I would solve this differently in a real life scenario, but this is still just for a test. So in a real life scenario, I will somehow make sure that each module has actually references to the other modules if I want them to be connected, but I might do it this way. As well, because why not? And now this says that they are missing a module map. And we're going through all the modules. And we will just say module dot module map modules equals to this. Yeah, we will get rid of those. And of course we need to set it over here. We'll get rid of those one by one when we actually implement them. So this will have this as well. Let's have it as an empty array object. We will waste some memory. So for each output, we're gonna need to do this. So that means that I created this pulse. Of course, this kind of means that right now, the first thing that we're gonna have to do is actually implement the button. And not like this, because this is its name, the name is button, and it outputs are broadcast. We don't want the broadcast. We can set that the broadcast has an input that is the button when we actually want to do that, and we don't want to do that, but on the, let's call this modules, otherwise we have too many inputs. That's a string array. Oh, I'm indexing in the push method. Yeah. So now we're going back. We implemented the button. When we push it, it sends out a pulse to all of its output. So we have this thing, and this should implement the receive and the modules. And it says when you receive a pulse, for each of your outputs, send out that pulse. So it just does buff. As I said, this is totally similar to what the button does, only the button is connected in such a way that it we have that, and we also can push it. And this is quite okay. We have an initial state on the flip-flop. And let's see. They are initially off. And we will have another type here that says module state. I don't want to use high and low for that because those are different things and we might mess them up. So the model state is on and off of the state of the module. The pulse itself can be low and high, so it will be a bit easier to do. So the state is a module state, and this can even be private. I want it to be private, to be honest, because why do you care? If I want to debug, I might add a method that outputs it, but that's a different thing. So we have a state that is initially off. And we have a receive thing. Let's read the spec. If a flip-flop module receives a high pulse, it is ignored and nothing happens. However, if a flip-flop module receives a low pulse, it flips between on and off. If it was off, it turns on and sends a high pulse. This is the spec. So it says it doesn't matter on which input it receives it. So if it receives two sets of pieces on two inputs, we're going to send out two pulses or ignore them or however. What we will do, we'll actually check first whether this is a correct thing. So we want to see that inputs, this dot inputs contains, includes input. If this is not true, we throw this, which means something weird happened. Otherwise, if a flip-flop module receives a high pulse, it is ignored and nothing happens. If pulse is high, bye. Otherwise, so we're receiving a low pulse. If we were off and this thing cropped up, if we were off, that means that we turn on and send a high pulse. So this state is on and we are sending a high pulse. Else, which means that we were off, on, and the state becomes off and sends a low pulse. So that is the behavior of the flip-flop. So now we have the most complicated one. Remembers the type of the most recent pulse received from each of their connected input modules. Just a sec, first we need this. Why is this? This is correct. They are initially not low, it's initially off. And now we have a problem with the way we manage things because the inputs are full, but we need to also have a map of something else. We need to have a state map. States, actually let's call them, which are an array of module state. No. Let's see. This is the memory, and that is a pulse array. So this memory needs to be just as long as all the inputs. But initially, when we set the impulse, we didn't set that. So we might want to do something like this in the processing of the input. Where it is, where it is. So we have all the modules when we're processing the module, when we're processing the inputs, but we don't know the input. So we're gonna say modules. We're just gonna add, because right now we have an array and a map that are basically pointing to the same object. So what we will do, modules.filter, where the type is a conjunction. Let's just call it module. What type of module? It says it's a broadcaster or a flip-flop or a conjunction. Well, it's not. Yes, we need that because now module is a conjunction, and we can say on the conjunction we're missing the modules thing. We can just add a function on the conjunction that says set memory or reset memory. And then we say this memory is array that is as long as the inputs, and we're going to fill it with low because they initially default to remembering a low pulse for each input. So we will have this code on each receiving. If this is not a valid input, that is invalid. So we get the index of that input, and now when a pulse is received, updates its memory for its input. So first we need to update the memory of for that. Then, if it remembers high pulses for all inputs, so we say if this dot memory dot every pulse is high, then each of our outputs receive a low pulse. So that's what I say. This is kind of a NAND. So it ends all of them, and if it's high, it pulls out low. And if all of them are high, it puts out low. If some of them are low, it puts out high. And we definitely don't want to reset the memory, otherwise we just do this. We might optimize this a bit, but to me, it seems quite okay. I will add the module map here as well. What is this missing? It says I don't have a receive. So this just does nothing. Let's see the untyped. And that's all it does. Let's see if this actually compiles, and if it doesn't, why. This actually runs. And it says I don't have a module called broadcast, which is totally correct because it's not called broadcast, but it's called broadcaster. And that part is not type safe. That part. So now let's say that we're gonna press the button and press it low. Oh, one thing that we forgot, we actually needed to reset the memory for all of them, otherwise we would have gotten some errors. I will add another thing here that we might want to use. We'll add the debug property, which is a maybe, and it's a boolean. Not private, it's definitely public. Hmm. Yeah, ugly code. Or, yeah, let's use this thing. That way we can actually use it and we don't need to add anything else. Because let's see, package JSON, I will add this thing that actually this sets the debug thing. We might use it a bit because let's go through the modules. And when we receive, we can just say, no, not on the button. If the button receives throw error, it's totally fine. Otherwise, if debug, yeah, this is okay. Well, who are you? There's one broadcaster. What do you mean you don't have debug? Of course it can be undefined, it has a question mark. Well, now it seems they're not unused parameters anymore. So we just press the button on low. If we run it like this, nothing happens. I mean, nothing should happen. Except maybe a error. So we will need to actually debug it, but let's start with debugging it this way. npm run start debug 20. It immediately crept up, which means none of those things got set. So yeah, first we did that. The memory seems okay. The start seems off. But when we run this button press, it says these modules of output. Did we forget to set the modules on the button? Yep, we did. Did we forget to set the modules on everything else? No, we didn't. It's done here. And we can't actually use them in the constructor because we don't have that. We might be able to do it, but it's gonna be a hack. And this is what I was talking about when I said that in a proper application, I would have that part set in somewhere, and we have an invalid input. Broadcaster received low from button and flip-flop A received low from button. How did the flip-flop A receive low from button? What is the name of the broadcaster? It's broadcaster. Because we are stupid. When we are sending out pulses, we're sending them from us. So it's correct here, it's correct here, it's correct here, it's correct here. Here we're not doing that check, but we should, maybe we should. So yeah, that was one more bug that we had. But you can see that the components are talking to us. So let's compare this to what this thing says it happens. It says that broadcaster receives low from button. Got that. Flip-flop A receives low from broadcaster. Flip-flop B receives low from broadcaster. These are kind of inverted because right now we are synchronous, but it should say that that doesn't matter. Let's see that. Okay. Pulses are always processed in the order they are sent. Oh, damn, this doesn't work. Okay, we might need to change a lot of code to actually do this, because now we will need to add something that's akin to a system clock. And pulses sent to A, B, and C are belong to the same clock, but they don't belong. The pulses sent out by A don't belong there, because right now we're doing something that's very akin to, let's say, depth first search. So all the pulses that are taken out from A, all of them will get, all that flow will have that. And in general, we do have the same pulses as here, only the ordering is totally wrong. And we will need to do that, because this needs to be done before this. So we need to have a system that will have a clock, and then we can tick it or something like that. Anyway, we will implement that in part 2 of this. Thank you for watching so far. Don't forget to click like and subscribe, and we will continue in the second part.